Okay, so in that last video, we just talked about the general idea for what end behavior was, and it was the value of the function as x approaches either positive infinity or the value of the function as it approaches negative infinity. All right. So if we had the graph, we could answer the question pretty easily. Right. As you go to the right forever here, as x approaches positive infinity, the value of this function is headed up. So it's also f of x is getting towards positive infinity as well. But as you go to the left, as you go to negative infinity on the x values, the f of x values, the y values are decreasing. Okay. So if you have the graph, you can kind of tell what the end behavior is going to be. Now, in practice, whenever it comes to polynomials, there's really only four cases. Okay. If you look here, these are going to be all four of the possibilities. Either it's going to go, up and up, like this one does, or down and down, or we say this would be considered down and up as x approaches, as x approaches negative infinity, it goes down. As x approaches positive infinity, it goes up. Or you could have up and down, right? And really, the only two things that you need to know to tell which of these four cases you're in, you really just need to know the degree of the polynomial and what the leading coefficient is. Okay. So this polynomial here, to determine what the degree is, you just look for the highest power. All right. It doesn't always have to come up front, but it usually does if it's in standard form. So this is a degree 5, so I know it's going to be an odd degree polynomial because 5 is an odd number. So I know it's going to either look like this one or this one when I go to graph it. But the leading coefficient is that coefficient that's attached to that 5th degree term, right? And since it's positive, right, since it is greater than 0, right, positive, that just tells me that I know that the general shape of the graph is going to look like this one. And so that gives me enough information to tell what the end behavior is. Okay. So if we, I'm just going to throw up something on Desmos just to drive home this point. Anything that's to the second power is going to be an up and up. If it was to the fourth power, also up and up, right? As long as these exponents are even numbers, the general graph is going to be the same. But if that leading coefficient is negative, this negative number out there, that of course just flips it upside down, right? And whenever it comes to odd powers, whether I'm dealing with something to the third power or to the fifth power or the seventh power, if this is ever an odd number, this is going to be the general shape of it. Of course, if you put a negative out there, it flips it, makes it go the other way. So if you'll just, remember the basic cubic function, this one, and the basic quadratic function, this one, as long as you know how to flip something across the x-axis, I think you should be able to feel your way through these. All right. Now, even if there's a bunch of other terms there, like x cubed minus 4x squared minus 8x minus 7, all right, it still has the same basic end behavior, all right, as the regular cubic. It goes down and to the left, and it goes up and to the right. As long as the degree here is to the third power, it's going to have that down and up look, right? If I switch this to the fourth power, it has that up and up look. All right, that's the idea here. All right, let's go ahead and look at a couple of these examples. All right. Identify the leading coefficient, the degree, and we're going to answer the questions about the end behavior here. All right, so on number 1, The leading coefficient is just this -2. Bam. The degree is a 2. Now that tells us which of our 4 cases that we're going to be playing with. All right, because the leading coefficient's negative, I know we're there. And because the degree is an even power, I know that we're here. Okay. So I know that the general shape of my graph is going to be one of those down and down functions. Okay. So as x approaches negative infinity, this function is headed downwards. As x gets bigger and bigger this way, the y values are going downhill. So f of x is negative infinity. As x goes to the right forever, that's what this part means, as x tends towards positive infinity, the value of the function is also negative infinity. It's down and down in both directions. For example 2, leading coefficient is this number here. Okay, that is a positive. That's the important part. The leading coefficient is positive, and the degree is 3. It's an odd number. Okay, so because I have a positive and odd number, I know that my general shape is going to look like this. So as x goes to the left forever, as x goes to negative infinity, let me draw that graph. As x goes to negative infinity, the value of the function is pointed downward towards negative infinity. And as x goes to the right forever, as x goes to positive infinity, the value of the function is also positive infinity. Okay. That's how you find the end behavior for polynomial functions.